we need to find out the derivative of the following. We'll begin by first considering u, which is a function of x, to be equals to tangent inverse of 2x over 1 minus x squared. And we'll consider another function v, which is also a function of x, to be equals to the inverse cosine of 1 minus x squared divided by 1 plus x squared. Now, the goal will be to find out derivative of u with respect to derivative of v. To do that, we'll have to first find out derivative of u with respect to x as well as derivative of v with respect to x. But what we'll do, we'll try to simplify u and v. So here we will make an assumption. So let's suppose that x is equals to tangent of theta. And we will substitute here in place of x to get u equals to tangent inverse of 2 times tangent of theta divided by 1 minus tangent squared theta. Now 2 times tangent of theta over 1 minus tangent of theta, so tangent squared theta, so that's actually tangent inverse of tangent of 2 theta. Here we have used an identity. That means if we have tangent of a plus b, that will be equals to tangent of a plus tangent of b divided by 1 minus tangent of a multiplied to tangent of b. In our case, if we consider a to be equals to b and both of them are equals to theta, then we have tangent of theta plus tangent of theta, which gives us 2 times tangent of theta in the numerator, and in the denominator we have 1 minus tangent of theta squared. And this will become equals to tangent of a plus b, but since we have considered a and b to be equals to theta, so tangent of theta plus theta will give us tangent of 2 theta. Right. Now, immediately this gives us u equals to, so tangent inverse of tangent of 2 theta will be simply 2 times theta. Right. So here, u is given by 2 times theta. We have considered that tangent of theta is equals to x. So that would mean that theta will be simply equals to inverse tangent of x. So this is the value of u, and let's label this as number 1. We'll come back to it. We'll now try to simplify the expression for v. So here also we are going to make a trigonometric substitution. So let's say we are going to consider x to be equals to tangent of phi. Now that means we have v equals to cosine inverse of 1 minus tangent squared phi divided by 1 plus tangent squared phi. Now 1 plus tangent squared phi, that's an identity. So let me state that identity. The 1 plus tangent squared phi is given by secant squared phi, which will make v equals to cosine inverse of 1 minus tangent squared phi divided by secant squared phi. Now what we have, we will take the first term in the numerator, which is 1, and divide it with secant squared phi, and we know that the secant squared phi is actually the reciprocal of cosine squared phi. So we have cosine squared phi minus the ratio of tangent squared phi to secant squared phi is going to give us sine squared phi. Now, in doing so, we can use another identity, which is cosine inverse of cosine of 2 phi. So here we have used the identity that cosine of 2 phi is equals to cosine squared phi minus sine squared phi. Right. Now that means we now have a simplified form for v. So v will be equals to, so cosine inverse of cosine of 2 phi will give us 2 times phi. And since we have considered tangent of phi to be equals to x, so that means v will be equals to 2 times inverse tangent of x. So we have obtained an expression for v as well. Now our next task will be to take the derivative of u and v. The derivative of u with respect to x is simply equals to 2 times derivative with respect to x of the inverse tangent function. The derivative of the inverse tangent function, that's a standard formula giving 1 over 1 plus x squared. Now similarly, when we take derivative of v with respect to x, so this is also going to give us 2 over 1 plus x squared. So this is du over dx. And finally, we can find out derivative of u with respect to v. So that will be derivative of u with respect to x, and we divide it with derivative of e with respect to x, which is going to give us 1. Now that means the value of the following derivative is a simple value with a value equals to 1.